Today, we are going to discuss AutoML. It's a low code, no code machine learning framework in Databricks. We will go through some theory, we'll do some hands on, and we'll try to complete a classification problem using AutoML. So let's dive into it. Many years ago, when I was inexperienced in solving machine learning problems, my fingers would get frozen. I would stare in the blank screen for long, wondering how to even start. AutoML could help us in such situation. It is a glassbox, low code framework. Glassbox because it set up everything for you in a transparent way. It gives you all the artifacts, it gives you all the results which you can use, which you can see, which you can learn from. It's a low code framework because you don't need to write any single line of code. You just pass the data, you pass some configs, and bang, you're done. You just hit the button, and behind the scene, AutoML framework would create all the artifacts required for that machine learning model. AutoML was launched in Databricks in 2021. As I just said, it is a glassbox framework and it produces the notebooks which you can run again. You can find it in experiments under the AIML section, which we'll see shortly. And it's tightly integrated with the platform, for example, MLflow, Delta Lake, Unity Catalog, etc. AutoML is for all the data professionals. If you are a data engineer and you want to quickly prototype any ML model, you can use AutoML. Or if you are a data scientist and you want to create a model and which could be the baseline, and then you bring your knowledge, bring your domain knowledge, bring your expertise to beat that model is a good approach to build the machine learning models. And it also helps fast moving teams where results are more important and you don't need to make it a perfect solution now. You need to deliver it quickly and see how things are appearing based on the parameters, right? So it helps those teams who are very fast moving as well. For AutoML to work, you actually don't need a lot of setup, which we'll see shortly. First, you need to select the dataset because that's the most important step to feed it into the AutoML, and only then it will be able to build a model for you. Then you choose the problem type, whether it's a classification problem, whether it's a regression problem, or forecasting problem. In this video, we'll see how we can solve a classification problem. Then you pick the target column and what is the evaluation metric. For example, it's ROC or it's a RMSE metric. And finally, you will set some timeout or a runtime, training time, thresholds, which will help to set some boundaries. And with all those configs, you just need to press enter and bang, everything will be done for you. And let's see how it works in a real demo. Okay, so now we need data for creating the machine learning model through AutoML. In fact, we also need compute. So we now will quickly see how we can do that. Okay, so in order to grab the data, I'm going to Kaggle website and I go to the dataset section here and I select classification, and from here I select diabetes. So we'll find a database or a data set which will have data around diabetes, which can predict whether a person can have diabetes or not. So I will save this data. I have already saved, and then load this data into Databricks and create a table. So for that, we just go to Databricks and we have a few options here. I go to data engineering and then data ingestion. And here I select this one, create or modify table, and then select the downloaded data here. So this one. Okay. So I've already created a table, or maybe I will just show you. So if I select like this, it will it is saying that this data is already there. So I will just say _1. So since this table name is unique, so it will create this. So I just need to press the create table here. All right. So once that is done, I can show you how I can query it. So I go to SQL editor. Okay. And I run this data set. So you can see we have a gender, age, hypertension, heart disease, smoking history. So all these columns, so which will help us to predict whether a person has diabetes or not. So we have this target column as diabetes, and it has numerical values. So 1 indicates whether you are diabetic, and 0 indicates you are not diabetic. Okay, so to run AutoML, we need a cluster. So I have already created one cluster here, but I will just show you few things which are important, which I have considered for this one. Okay, so first thing is this part and this one, and probably this as well. Okay, first thing is you need to check this box because you are telling Databricks that create me a cluster which is machine learning enabled. So all the libraries related to machine learning are pre-installed in this machine when you put the checkbox on. Okay, then since you are doing the experiments or learning, better keep it in a single mode so that you don't pay extra for unnecessary compute. And finally, don't forget to put terminate after 10 minutes because that's quite optimal and you will not get extra charge on the DBUs. So if you notice that the DBU usage is not too high, it means I think we can do this experiment with fairly low price. Okay. Now, since it is running, so let's go to the experiment, and in this section, you will see many options. But here we will be using the classification problem, right? So I will be going here. Okay, so once you land in this page, you will see this option which was not there before. And I think Databricks is slowly going away from AutoML and adopting the Gini code or AI-driven solutioning, right? So we'll talk about this later with a separate video. Today, let's focus on AutoML. So now, this is the overall process for AutoML. You configure it, then you join any new feature and enrich the data set, then you train it, and then you can get the output and you evaluate it. Okay, so here we'll select the cluster which we just saw in a few minutes back, and here I will browse the data. So this was the data we saw earlier, so it's in the default schema, and I select it. Then I select the prediction target, which is diabetes, and I rename this model as, let's say, diabetes prediction model, let's say 2, because I created one before. And then select advanced configs. So here you will see the different evaluation metrics for classification. So you can see F1 score, accuracy, log, loss, and so on and so forth. I'll just keep it as a default one. And then all the experiment will be saved in this directory. And these are the framework which are selected by default. So I will just keep it as is. You can uncheck it if you want to. The timeout activity, I will just try to make it a bit lesser to save my cost. And time column for training, this I will just keep it default. And then positive label, I will just say as 1, because in diabetes column, it's 1 or 0. So 1 means you are diabetes, so it's a positive. Hence, I put it as 1. And rest, I can leave it as is. And then I see what is there, join. So here you can select data from feature store, which is not configured yet. So feature table is not there yet. So we will also omit this and go back to the main page. And on the right hand side, if you see, there is a window for handling the imputation. So if there is a data missing for a particular column, you have auto mode, and then you have most frequent and constant. So keep it auto so that it impute it and find the best way to impute a particular column if the values are missing. So here I just press the start button. That's it. So these are the configs we have done. Now I'm entering the AutoML process. And I think it will take some time. So I will pause my video and come back in a few minutes. Okay, so the notebook has run. This is the first instance, and this is the second one, underscore 2. And it took around 11 minutes. And if I open this instance, it will take to me a notebook, which is a driver notebook. And if you scroll down, there are links for 3 different notebooks. So let me open the data exploration notebook first. So this notebook is about exploratory data analysis. So it has done some groundwork on understanding the data, and that could be quite useful for anyone to understand it. And it takes a lot of time to do these analysis, and imagine you are getting all these things ready made, readily available. Even for data scientists, this is a quite useful feature. So here for overall data set, it has given the stats, it has given the alerts, like how many duplicates are there. There are 48 rows having duplicates. It is also talking about correlations between the columns, right? And there are a lot of zeros, etc. Then if I go down, there are variables I can select. That's a gender. That's nice. Age. Okay, cool. So from here I can select variable. So let's say I select gender. So it tells me the most number of records having gender as female. Other are very less. Male are second highest. And if I click this more details, I will get more granular level of data. So here you can see that females are 59% and males are around 41. Others are very less, right? So this is what it was being depicted here. So we basically, yeah, there are a lot of details. We can go through that later. So this is quite useful and we can use it, right? Then let me open the best trial notebook. So this is the notebook, which is the best notebook. So let's come to this notebook a bit later. So let's try the ML flow experiment. So in this notebook, they might have done a lot of experiments, right? Let's see what are those experiments, right? They have done like so many experiments in last 10 minutes, right? And this is a metric. So this is the metric. And they have put some naming over here. It looks like this is the best one. And if I see the model, it's a XGBoost classifier. And here, if you notice that this is the one, XGBoost classifier training. So this is the best model notebook, right? But they have done a lot of experiments in other models, using other models, like they have used logistic regression, they have used decision tree classifier. But this is the best one, okay? So if I click this one, it tells me about all the details of that particular model. What was the model metric, and then artifacts, and yeah, many other details. And I think from here we can also register this model. So registration is, these are the experiments you are doing, but in order to use it for your production or any application, you need to register that model. And if I click this, it gives me 2 options. And probably I just type ddx underscore ml underscore dev. So this is our catalog, and then default. And then let's say I put some name over here, predict diabetes, something like that. So this is the model name. And if I register it, so it has started registering it. So we'll come back to that. I think it will take some time. In the meantime, we will go to that final notebook for the final model, which is the best model. So you can see that this model is the best model, and it has been coded by AutoML. You don't need to do anything. All the pre-processing, all the machine learning process like training, validation, testing, split, and then using the appropriate model, etc. Everything is being done automatically by the model itself. And I think there is some important thing which is SHAP. I think it will come at the end. Yeah. So this is one of the important feature. So it gives you the feature importance, and by default it is enabled as false, so that because it takes a lot of computation resources. But if you want to plot it and you want to check the feature importance, you can use it and you can enable it. We will create a separate video for this, so stay tuned. Now coming back here, let's check the catalog whether the model has been registered or not. So if I go to this catalog, dbxml dev, inside the default schema and the model. So if you see here, this is our model, predict underscore diabetes, right? Now it's ready to use and you can serve this model and consume it for your applications. So here overall what we saw is we were able to load the data very quickly, right? We don't need to write any code. Then we used AutoML process. We provisioned the compute and enabled the cluster. Then we did some configuration changes and then we run the AutoML. It did everything to us and produces a model which we can use it and can serve it. And also the entire process was quite transparent, right? So everything was done and I can access and I can use it. In fact, let's say this is the final model, right? And now any data scientist can use this as a base model and they can tweak it. They can do feature engineering. They can do anything, any data enrichment on top of this and make this model even better. So a lot of hard work or heavy lifting has already been done by the AutoML process, and they can now focus on results and try to get more insights out of it. Okay, so I think we are good for now. This is how AutoML works, and under the hood, it does the feature engineering, it does the parallel training, and it does the logging. It has SHAP explainability. It generates the notebook for you, and this is the AutoML lifecycle. It does some data profiling at the start, creates the baseline model. It does the parallel trials. It selects the best model from those trials, and then it passes the final outcome to you. So where AutoML shines? So for fast prototyping, if you want to quickly design something for education, you can see the fine-tuned notebook and learn from it. It gives you everything where you can see and check. It's very transparent, right? It gives you the first level of baseline and then you start building on top of it. So for me, it's a very important feature of Databricks. Where it struggle is if you have to do some custom pre-processing, the customization is a bit less. You don't have much control except passing those configs, right? And then for SHAP calculations, you have a lot of compute costs, etc. But there is something which I noticed that AutoML is not going to support in the runtime 18.x onwards. And they have also introduced Genie code. As you can see, it was prompting to use that. So it means looks like there will be some transition from AutoML to Genie code. And we'll see how we can use the same model with Genie code in our next video. Okay. I think still it was a useful exercise to understand what AutoML is, how actually it could do things, and it's mainly AI driven. But the Genie code, it's now natural language driven. You put the prompts and it will create models for you. Okay, I think very new, exciting features are on the way, and we'll explore them. So thank you so much for watching.